Welcome to this tutorial in which we are going to look at various examples of constructions, and the main chief is about construction using the set square, though we are going to go an overview of how to draw some special angles, and basically that's the main thing in this, and also do an overview of also reviewing loci of inequalities just to understand how it basically works. So let's have a quick word of prayer before we begin. Father, Lord in heaven, as we start this session, you being the greatest mathematician I've ever known, teach us with the stillness of your voice this particular course. Yes, I may pray. Amen. Have your tools nearby you that we may be able to journey together. Have your geometrical set, rubber, ruler, and everything, even your pencil, if need be, which is also important. So we're going to begin with first special angles. Let's quickly begin with them. Most common one, 90 degrees, but I'm just going to have it on one diagram. 90 degrees is basically a perpendicular. I believe you know that. So I'll just pick any dimension. So basically, in the first case, I would like to drop a perpendicular here. So for example, in this case, I'll just extend greater than the half of that length, draw two arcs, and then I'll just join. You'll be able to prove that on your own time. You'll notice that this will be 90 degrees. Next, how to draw 60 degrees. Let me have it drawn here. 60 degrees, I believe you can see that. Just draw a circle with a convenient radius. And then with the same radius, stand on one side of that circle, and then have that arc with the same radius. Then the moment you join, you will be having a 60 degrees angle on this side, and on the other side it shall be 120 degrees. Next, the one that usually like to ask you is, for example, 75 degrees, 15 degrees, 135 degrees. How do you draw that? So basically, we begin by drawing 60 degrees here, but allow me to draw it on this side. So I'll have my circle of a convenient radius. Then with the same radius, stand on this side, have that, and then whatever that shall be here is 60 degrees. This is 60 degrees, but our aim is how to draw 75, 15, and all those kinds of angles. Now, assuming that you are dropping a perpendicular here, what angle will have remained here? This will be 30 degrees. So if I subdivide this into two, and how do you subdivide angles? Just draw two arcs on the two bisectors, on the two lines that are joining together, and then how to bisect the angle, stand on one, make your compass leg stand on one side of that arc, draw an arc in between those two lines with the same radius, take the second position and draw an arc, and with that, if you join, you'll have subdivided this 30 degrees angle into two. So here it should be 15, it should be 15. So basically, if I sum up the total number of angles that I've drawn, this one, we said it's 60. This one is 75 degrees. It ends on this line. I believe you can see it up to here. So the whole of this is 75 because of this 15. Prove that at your own room temperature and pressure. But something you'll also note, in tandem, we'll have drawn 105 degrees on the opposite side. If you subtract from 180 angles at a point, here is 15 plus 90, you'll have 105 degrees. So if they ask 105 degrees, just challenge yourself in your mind, know how many angles you need to draw. For example, 105, I'll draw 60, subdivide the remaining 30 into 2, I'll have 15. So this is 15 plus 90 is 105. What of 135? Now the question is, 135 comes from how many, what angle? Now you'll notice that 135 comes from an angle of, after constructing 45 degrees, of course, 180 minus 45 gives you 135. So basically, if I subdivide my 90 degrees after dropping a perpendicular, and then subdividing my 90 degrees into 2, for example, in this case, I subdivide it here. I draw those two arcs. I believe you can notice that. Draw those two arcs with the same radius, with a different radius. This one I have no problem. Just extend it up. Draw two arcs. If you join those two, you'll notice that this is 45 degrees. What of the remaining one? Is 135 degrees. Those are the very special angles they can ask you to play around with. And if you want to continue further, you should know just the trick. Don't cram, but understand the trick. How do you subdivide angles? You just draw two arcs on two bisecting lines, drop that particular line and be able to draw. So that is the main thing. Know how to bisect angles. That's how to do it, and how to construct special angles. So the very special angles you need to know how to construct, which are basic angles, is 90 degrees. When I call them basics, because the moment you just construct them, it will be the same. 90, we have 60 degrees in tandem, 120 degrees. These are the various angles. You can draw them directly. The rest will be based on what we have here, subdividing them and making them quite clear. Now, I would like to draw two lines here and be able to show you how we can draw a parallel line by the use of a set square and also by the use of construction using a compass. If you're told only a compass, how will you do it? Quickly, in this case, let me begin with the main one that we wanted to work on using a set square. Now, this is a set square of 45 degrees because the corners here will be 45 and this is 90 degrees. But also the one for 60 degrees can also work. All of them are the same. Now, how do you go about this? Ensure that, for example, if I want my parallel line to start from this point, point B, and this is point A, what will I do? I'll have my set square put an edge on that particular side that I want to transfer. For example, this is the line I want to transfer. I put one side of my set square touching that edge, like that. And then my ruler, I'll place it on the side I want to slide my set square on as I move it towards the other side. So for example, in this edge, I'll put it here. And then I'll now slide it in this direction. After sliding it here, notice it will touch that point. The moment it reaches there, I just stop and draw my line there. And you'll have a parallel line. Let me repeat what I've done. For example, I want to move this line this direction. What will I do? I'll pick my set square, put an edge that is straight on that side I want to move, then put my ruler on one side that will be the sliding edge, and then just slide it to the point I want to draw my parallel line, and just draw it there. Notice it will be parallel. There will be parallel lines. What of construction? In constructing, you'll now need 2 points in which you'll draw 2 arcs and construct that line. For example, I can have it in this manner. For example, I have measured a distance x from A to this point. and you wanted to transfer it, for example, from this point C. What will I do? I have that length. I'll simply take that specific length to point C, draw an arc, and then eventually now I'll measure that length. If, for example, you had been told to measure the length, but for me, because I didn't measure, I'll just pick it from here. From here, I draw that, and the moment I draw this particular line to C, it will be parallel to that. I believe that one is the one you knew. Now, what about the most common question about subdividing a line several times? I've just remembered that. Allow me finish with that. And you have been told, for example, subdivide it how many times? For example, I've just simplified it for you. For example, you had this line here, and you have been told, subdivide this line into, for example, 7 equal parts. What I'll simply do, I'll simply measure the length here, and then subdivide it by 7 so that I may be able to know the length of each small segment. After that, I'll simply come with that particular measured length, draw arcs on the line I want to subdivide. Now, so basically, I'll come plot it like that. And at your level, the reason as to why I'm just doing this is because it will always be in the form of a triangle, unless told otherwise. You have that. So what you'll do, this line you'll just draw it yourself because it will be in the form of an angle. For example, let me just return another one, the one that will be common to you. This is how the question most of the time will come up in. So for example, you have been told you have a length up to here. So the first thing will be ensuring that you have those particular lengths. For example, up to, you have been told subdivide it several times. For example, those are the number of times you have been told to subdivide it into. This one, you'll drop it to the first point. The last one coincides with the first point here. And then you simply draw parallel lines. So I'll come here like this, put an edge there, and then slide it. Simply come like this, slide that like that. Come here, slide, draw. I believe you can see how simple it now becomes. Slide it, draw. Slide it, and you draw. Notice you'll have subdivided it very quickly. So that's how to use a set square. Now that is it. Now finally with inequalities, because I said I want to finish with that. Inequalities, if I have, for example, an inequality ax is greater than xb, it simply means my answer lies in the region greater than ax. So when I'll be drawing, for example, I have that line and x is somewhere here, it will mean it's greater than or less than is simply a dotted line at point x. But I want a region, my answer lies in the region greater than ax. So I'll simply shade that region like that. Or for example, I find that I have CB is less or equal to BP. I'll simply now have this one as C and P, and my B will be that manner. So it means my answer lies in the region less than this. So I'll simply shade that and it will be a continuous line. I believe you have seen the gist of what is happening. May God bless you.